Hello, my name is John Oberlin, UMBC student in the Data Science graduate program. I'm doing the cybersecurity track, and my capstone project is looking at IoT security, specifically early detection of IoT botnets. So why IoT security? I just, one, think it's quite intriguing. IoT is this cross between data science, the physical environment, and security plays a big role. Um, it's trying to, we're trying to solve streaming big data problems, many applications for AI and machine learning. Um, Security is important because IoT is increasingly making decisions in our physical environment. Um, and what we're trying to do here is implement some detection systems that will assist the cyber analyst in researching and making a decision on if this threat is something that needs to be acted on or not. Also, there are smart networking controls are becoming more common. So where, you know, if a threat is detected, the state of the network can actually be changed automatically. Approaches to intrusion detection. We're going to be looking at analysis of network traffic. You can also look at individual machine or devices system calls or their CPU and memory usage. But for this project, we'll focus on network traffic. You can look at traffic as whitelist signatures and blacklist signatures. Example whitelist signature would be like a successful transmission communication protocol TCP handshake um, versus a blacklist signature where you have that same handshake supposedly trying to happen, but the attacker is flooding um, the server with synchronization packets that are part of that TCP handshake. So you're kind of looking at what's the expected function of a protocol and what is like anomalous behavior. Um, you would also have the blacklist signatures would include known malware communications. Um, Also, there's so much data coming through, talking about 9 GB coming in within 10 minutes. So you have to be able to filter the packet, the network traffic packets, but you also have to balance that with getting the right amount of detail for cyber analysis analysts and also forensic experts for evidence collection. Um, Learning approaches for detecting intrusions. People have done natural language processing on the packet information itself. Deep learning, which can be compute intensive, so you might not be able to do the model training on the edge devices like the gateway for the IoT network because they're usually low memory, low power devices. So you would be doing that in the cloud and then sending the inference model down to the IoT net. There's graph-based approaches, um, and even without using machine learning, you there's been interesting studies on just how to display the patterns of packets coming through, and pattern recognition for humans is a natural thing. This project, though, will focus on a decision tree classifier, either random forest or the J48. Probably the J48 because its output is readable. So we're looking for helping the cyber analyst. So if our algorithm makes a decision, we want the analyst to be able to see how that decision was made. Data sources in general are packet capture files, these PCAPs. Um, they can be simulated over a tool called TCP replay, and they can be captured with tools like TCP dump or Wireshark, which is the point and click um, packet capture program, and then its command line version is T-Shark. I would like to test one of these decision tree models over multiple data sets. So we have these 4 data sets listed here. They all have the botnet malware version called Mirai. And there's different versions of that, so it'll be interesting to see how a model would perform across these different data sets. But they're all packet capture files, so they should all have the same type of features that can be extracted. Which, for example, here I took a PCAP into Wireshark, exported it as a CSV. This was filtered in Wireshark, I believe, to source and destination IPs of the known infected IP address. So the known infected device is labeled in this data set. And then I aggregated that to the different protocol counts. So these are the number of packets and for each protocol for each IP. The infected IP there at the top, 192.168.1.195. Something to point out is that it's using IRC protocol, where the other addresses are not, except for that second one. So I'd be interested in looking into, is that second one the command and control server that the attackers are using? As I've read, IRC protocol is often used for the CNC, the command and control server communications to infected devices. And this, the source here is from the IoT 23 dataset. So my contact here, johno2@umbc.edu. Check out the Google site for the project, or my GitHub, which also has some other projects on data security. Thanks. Bye-bye.